Good morning, Observatory fans and peeps and pipettes, and I am now an any-shape earther. There you go, killed all the birds with one stone. Round earth, triangular earth, octagonal earth, flat earth. We should all be any-shape earthers, right? Because really, till we sort the rest of the mess out, what does it matter, okay? Now, I had all this stuff on the board. All the sun and the Olympic swimming pool, and I was going to do all of that, right? And last night I went through and I did my reels for the night. I had finished doing my reels, okay? And then I get onto the computer. I'm just finishing up. I thought I'll go inside and start, doing the reels, the 1 minute 30s. And I put this on, right? I was just flicking through a couple of things on YouTube as I was cleaning up, right? And this popped up.
Moon, we have not been on the moon 100%.
Really?
I guarantee we have not been on the moon. I believe that it was, the whole space race with Russia. If you really look in the footage, if you look at actual footage of the moon landing, you just look at some of the materials used in the crafts, and it's like almost like tinfoil, and you're like, how did this travel through space like that?
Right.
It doesn't make any sense.
Well, as long as you've looked into it and it doesn't make sense to you, then it obviously never happened, did it? Dear oh dear. It amazes me the amount of people that cannot comprehend how something could happen. Therefore, they don't believe it to have happened. Everything that he was saying there has long been debunked, but because he can't make it make sense, it didn't happen.
The moon, we have not
Now.
been on the moon 100%.
Really?
I guarantee we have not been on the moon.
So this happened last night. I see Simon Dan rigorously defending the moon. Like, just because this guy, doesn't mean it didn't happen. And then I'm thinking, and I didn't post last night. So I was thinking about this. I get up this morning and somebody, this is the way it happened, okay, is having a little attack, a little dig at me and my pyramids, right? And he says they were obviously built over 20 to 30 years. Nah. And then he says, straight after that comment, or before that comment, Simon Dan would love you. And my ears pricked up like Scooby-Doo again last night when I heard his voice. Huh? Simon Dan. So he believes the moon landings, right? It's there in black and white, in audio black and white. But does he believe that the Egyptians built the pyramids, right? Because the person that said, oh, Simon Dan would love you, it just sounded like he already knew that Dan would go, pyramids? Of course the Egyptians built the pyramids. Because straight away, if we've got Simon Dan who believes in the moon landings and that the Egyptians built the pyramids. Now, people, I always say common sense. It's the ability to be able to distinguish between what's possible and what's impossible and between what's real and what isn't real. Now, Simon Dan, are you telling me that you believe the moon landings happened? And you believe that the Egyptians built the pyramids? Because if so, please get me on your show again. I mean, I did trip up with the laser. I put my hand up, right? But anything else I talk about, please come and have a go. I would love to. See, now what I'm thinking, there must be an opening somewhere in amongst all of the stuff that's out there. There must be an opening for somebody who can see things logically, right? Who has a critically thinking mind and who has plenty of common sense, enough to share in fact, right? Because, I mean, we want to be teaching the kids correct information, don't we? We want to be making sure that they know what's possible and what isn't possible, making sure they know what's real and what isn't real. We don't need to be filling their heads up with fairy tales still, do we? So, that was my morning, right? That was good. Now, last night, I had all, remember, well, I had the sun here, Olympic swimming pool there, big round roofing there, big numbers, billions. I had 468 billion on one, and people were nervous. I know they were nervous. All I have now are those four numbers. Right? Now, everybody knows what that one is, or should do. Now, let's get straight down to business. So I get my ears prick up when I hear something like that. Simon Dan. Just because you don't think it happened doesn't mean it didn't happen. Really, the moon landings. And then I did actually leave a note there before I did leave last night and said, you do understand that Apollo 11, before Apollo 11, we have Apollo 10 that went up, dropped to within 7 or 8 miles of the moon, took some photographs, shot back up, got back down, handed the photos over to Neil, Buzz and Michael Collins. Now, how did that happen again? And that was in May. So Apollo 10 goes up in May, June, July. 2 months later, Apollo 11 goes up. It's like buses, isn't it? It's like a shuttle service to the moon back in the 60s and 70s. I wonder if Dan knows about that as well. But he obviously believes that it was more than possible for all of those astronauts on 6 different missions who had never actually flown in a vacuum and landed in 1/6 of Earth's gravitational pull, all managed to land safely and get back. Far out, Simon Dan. Now I'm thinking, Sci-Fi Man Dan, or just Sci-Fi Dan. Sci-Fi Dan or Sci-Fi Man Dan? I like Sci-Fi Dan. Sci-Fi Dan. You know where I am, Sci-Fi Dan. I might have to do a little bit of digging around myself to see if you really do think that the Egyptians built the pyramids, because then we're cooking with some gas, aren't we, eh? Now, what this is my 3mm bulb, remember? The 3mm bulb. So, if the sun were a 3mm bulb, right? So we've got, the sun is a 3mm bulb. The correct distance to planet Earth, if we keep things to scale, if the sun were a 3mm bulb, what we do is we multiply by 108, right? Because there are 108 sun diameters, allegedly, between Earth and the sun. Now, if we multiply 3 by 108, we get 32.4 centimeters, right? So the sun, and in between the sun and planet Earth, if the sun were a 3mm light bulb, right, we have 32.4 centimeters. Now, a lot of people don't understand the 2-scale thing. It's quite obvious, right? Because in the comments you sometimes drop, if the sun was shrunk down to the size of a 3mm light bulb, because there are 108 sun diameters in between the sun and Earth, when we shrink the sun down to 3mm to keep things perfectly to scale, there are still 108 sun diameters in between Earth and the sun. So we multiply that and we get 32.4 centimeters. So what we have now is the perfect 2-scale size sun and distance to Earth. Now Earth, with a sun the size of a 3mm bulb, would have a diameter of 0.027 millimeters, right? So basically 27 micrometers, right? Now, this is all to scale, okay? This is what people need to understand. This is where people start to go, yeah, but it's a bulb, it should be. It's like, calm down, okay, listen, it's to scale. What we have is a sun with a diameter of 3mm. The distance of 150 million kilometers shrinks down to 32.4 centimeters. And Earth's diameter at the other end of that 32.4 centimeters becomes 27 micrometers. Okay? Now, because what we have up there is perfectly to scale, if the sun turned on from off, this is how that one guy this morning ended up saying, oh, Dan would love you, no, because of the sun remark. He goes, but the sun, it's always on. It's been on for billions of years, so it won't ever be off. It's like, oh God, I'm not talking literally, right? It's funny how things work out. Anyway, what was I saying? Right, 3 millimeter sun, 32.4 centimeters, and a 27 micrometer Earth, speck of dust. It would take, because everything is to scale, if the sun turned on from off, hypothetically speaking, okay, it would take, at the current speed of light and the current science, I call it Mickey Mouse science, right? It would take 8 minutes for the light from when it left the sun, the 3 millimeter bulb, it would take 8 minutes and 20 seconds to reach Earth. Because it is to scale, all right? It's not gonna happen when I turn the bulb on, but the science says, way up there, with the sun, that is exactly what happens, right? Because it is perfectly to scale. Because it's perfectly to scale, if we had this little this demo here, right, and we had it timed in, plugged in to exactly how the speed of light happens up there, we would see the light leave the bulb and it would crawl along. It would actually take 4.6 seconds for this bulb to radiate light, each of its 3 millimeter diameters, right? Because that's what they're saying it takes the sun. 4.6 seconds to radiate light the distance of its diameter of 1,390,000 kilometers. So, what we're going to do, we're going to put the sun up this way. Let me just close this a little bit, right? Just gives it a little bit more of a... Right, so what we're going to do, that bulb, it's the sun. Do it. We're here. We might as well do it. In it. Right. So here we go. The sun, it's up there, right? This nail here is the sun, right? That bulb is supposed to be there, but I didn't have them right up against each other. Then we have 32.4 centimeters, and we get to a planet Earth that you wouldn't even be able to see it. It's tiny, 27 micrometers, right? Speck of dust. So let's see what happens. We're going to turn the sun on. Remember, it takes 8 minutes and 20 seconds to cover that distance. Let's see what happens. All right, let's go about there. Boom! Now look at the shadow that Earth nail creates. All right? Boom. Yeah, but of course, because it's only tiny, they say. It's only tiny. Of course it's going to cover the whole, But the science says that this is to scale, right? So what we would need to do, like I said the last times that I did it, I need to go to the hardware store and say, hey, do you guys have any bulbs, tiny bulbs that take 4.6 seconds to radiate their light the distance of their diameter? And they would look at me as if I was crazy, right? Because nothing takes 4.6 seconds to radiate light the distance of its diameter until we get to the sun. But there, we get to UY Scooty. I feel sorry for UY Scooty. It's going to need some therapy, isn't it? So, now that we've gotten that done, what is it that I'm saying with this light thing? I'm saying light is absolute. They are saying it travels at 299,792 kilometers per second. Right? So we can get rid of this now, because we should all, I'm thinking this time, I hope people understood that. I can't make it any clearer, can I? Right? Let's get rid of this. Now, why am I saying that light is absolute? And why am I totally against the Mickey Mouse 299792? This is why. Got a good nose for weed. I'm sure I just had a whiff of it. Right. I'm saying absolute light. This is from the sun and stars, right? Absolute. And then on the other side, what's wrong with this? We've got Mickey Mouse, right? I'm not being nasty. I just call it a Mickey Mouse light speed because I think it's Disneylandish, okay? Now, absolute. I could only describe absolute as fast as our eyesight travels. Go outside, look up, Proxima Centauri, bang! See it straight away. It does not matter how far away a light source is. If it's powerful enough for you to see, you are seeing it live. There is no such thing as not seeing live light in the night sky, all right? So all of the stars that we see up there, you're seeing them live. That is what I'm saying, right? Now, they have the 299 million we're going to go for, 792,458 meters per second. Now, I've always said this is a very, very specific number. So what is the method? What did they do? What did they actually do with measurements, a speedo, a ruler, protractor? What is it that they did step by step to arrive at a number, 9 figures, right? 299,792,458 meters per second. How? Where is the mythology behind it? What did they do? How many times was a mirror spun? Which direction was it facing? How many times was the silver mirror made to split the light beam? What we need to know is how was this number, how did they come across this number, right? We've got all of these things in these encyclopedias and everywhere that he tripped over and was then able to work out the speed of light. She went out, no, they're all he's, aren't they? He went out and walked his dog, and when he got home, he was able to work out the speed of light. He made some pancakes and was then able to work out the speed of light. That's about as much information as we're getting, because none of them come down to the very specifics of how this number was reached. And all of you people that will start saying, no, everybody knows. Everybody doesn't know. You just presume, right? So this is one of my reasons for not liking Mickey Mouse speed of light, all right? Now, what else do we have? They like light traveling, light year. I was going to say light traveling without a source. A light year, right? A light year is basically light traveling without a source, because if a source goes out, they say that light still travels, right? Oh, that star could be billions of years old. You know, you're looking at it, but the light has taken so long to get there that the star that the light was coming from could already be snuffed out. No, rubbish. No source, no light. they've got light years, absolute light. There is no such thing as a light year. There can't be. Why can't there be? Because if a light source is going to reach you in the night sky, it's going to reach you live. It is not going to be delayed. You either see it or you do not see it, right? That's why there is no such thing as a light year. What else? We've got some astrophysicists, they've got this hobby. They have a hobby, right? And this is the hobby. Where is it? Where is one? There we go. This one will do. So, at night time, some of them go out, turn their laser on, leave it pointing up for about a minute, and then when they turn it off, they think that there is a 1 minute long light beam on its way somewhere, because light travels without the source, right? No, it doesn't. Prove it, they say. You know. So that's basically the light year thing, all right? We've got the ridiculousness, obviously, of the 8 minutes and 20 seconds. I mean, 8 minutes and 20 seconds for the light to reach us from the sun, okay? There's not a lot of common sense in this thought, because the sun has a diameter of 1,390,000 kilometers, right? And it's only 108 diameters of itself away from us, right? It's exactly the same scale as this. That is 108 diameters away from that. This is 108 diameters away from that, right? On that note, let's get rid of this now. What do I say about light? Absolute light. It's absolute. Light is absolute. What determines how far that absolute light radiates from a source is the power and the size of the light source. We have a 3mm bulb, right? It's traveling a distance of 32.4 centimeters to an Earth that is, look, it's not about Earth right now, okay? But it's there as a reference point. We have a 3mm bulb radiating its light. 32.4 centimeters, that it looks absolute, doesn't it? You could not say that isn't absolute. You couldn't say it's not 299792 either, right? Now, it's to scale. Let's, for example, multiply everything by 10. 3mm becomes 3 centimeters. The distance in between them becomes 3.24 meters. And Earth would jump up to 0.27 of a millimeter. Alright? But it's not about Earth. It's about the light source and how far and how it's radiating its light. So we have a 3 centimeter bulb now, 10 times the diameter of that one on there. And it's traveling 3.24 meters instead of 32.4 centimeters. What would we expect to see, right? I'll tell you what we would expect to see. The exact same as we saw from here to here. Why? Because everything is going up at the same ratio. We're keeping things proportionally equal as we rise, all right? Let's go times 10 again. So now we've got 30 centimeters. We've got 32.4 meters. And Earth would now be 2.7 centimeters, I do believe. Yeah, right? But it's not about that, right? 2.7. Right? Now, this continues, right? We say to ourselves, right, we've got a 30 centimeter, the sun has a diameter of 30 centimeters. We have a distance of 32.4 meters in between, and at the other end is a 2.7 centimeter or millimeter Earth, right? It's not about the Earth. How do we think the 30 centimeter light source would find it radiating 32.4 meters? I'll tell you what would happen. If you were looking at it from a distance, you would see more or less exactly the same as what you saw with this radiating its light to a 32.4 centimeter. Why? Because everything is increasing equally, right? That is what keeping things to scale means. Times 10. Suddenly, we've got a 3 meter light source in diameter, right? The distance becomes 324 meters because we multiplied it by 10, right? And Earth, look, whatever, it's getting bigger. It's not about Earth, right? It's about the light source and how fast and how far it's radiating its light. We have a 3 millimeter diameter sun. Going to be, yeah, up there, right? This wall kind of thing. We are just over 3/4 of a racetrack, 324 meters away from a 3 meter light source. What are we going to see? I'll tell you what we're going to see. Exactly what we saw down there. A 3 meter light source traveling 324 meters is nothing, right? It is exactly the same as a 1,390,000 kilometer diameter sun traveling the distance of 150 million kilometers. It's exactly the same, right? This up to here, all instant, bang, absolute light. You couldn't say it isn't, right? But you could not say it isn't 299792 either. This is the thing. When you're on a planet like this, right, and you've got these two optional light speeds, there is nothing down here that would show signs that it's either absolute light that's making something work or Mickey Mouse speed light. Because when something travels at 299,792 kilometers per second, and you live on a planet with a diameter of only 12,742 kilometers, where on earth are you going to see the effects of the speed of light, right? This is the thing. The only time that the speed of light would start affecting things is when you start coming up to these diameters. Now, I'm keeping things perfectly to scale, okay? And so let's put a line under that. Now, how do we know I'm keeping things perfectly to scale, right? We've got a 3 meter diameter light source, right? Alexa, what is 3 multiplied by 108?
3 times 108 is 324.
That is how we know that what I'm doing here is staying perfectly to scale, because there are always 108 light source diameters between Earth and the light source. Let's bump up. We'll skip. We're going to go from a 3 meter light source to a light source with a diameter of 149,896 kilometers. Right? So we're doing all the light sources, boom, 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 and we've suddenly climbed to a light source that has a diameter of 149,896 Ks, right? Now, Alexa, what is 149,896 multiplied by 108?
149,896 times 108 is 16,188,768.
Right, we've got 16,188,768 kilometers. And then planet Earth, look, let's do it just for the sake of the reference point. Alexa, what's 149,896 divided by 109?
149,896 divided by 109 is approximately 1,375.1927.
Right. Earth would have a diameter of 1,375 kilometers, right? Now, if we have a light source with a diameter of 149,896 kilometers, Earth would be at a distance of 16,188,768 kilometers. And Earth would have a diameter of 1,375.5 kilometers, right? Now, what we have here is a light source that is half of the number of the speed of light, right? Now, this light source at this diameter now takes half of a second to radiate light the distance of its diameter, right? As soon as we get up to these sizes for the diameters of the light sources, we are now starting to mess around with kilometers per second because of the speed of light. So this light source now, at 149,896 kilometers in diameter, takes half of a second to radiate its light the distance of one of its diameters, right? Because of the Mickey Mouse speed of light. The next one, see, that's 149. The next size up, if we double that, we actually get to a light source with a diameter of the kilometers that it takes light 1 second to travel, right? Now, absolute light, the way I'm saying light works, as we double each light source, the power obviously doubles as well because it's getting bigger, it's doubling. The distance is doubling, diameter of the light source is doubling. The distance that the light source would boom, like it does down there, also doubles, right? Now this is where the difference is. What I'm saying is light is absolute. What determines how far that light source travels is the size and power of the light source. They don't think that. For some reason, even though their light source is getting bigger and more powerful, because when you get bigger, you do become more powerful, but that's not enough to overcome the Mickey Mouse speed of light, right? And I'm saying it's wrong. When we get to 299, we now take 1 second to radiate our light the distance of our diameter, but with absolute light, it's doubled again. So when it radiates its light, it's boom, absolute, and more powerful. 1 second per diameter. I don't think so, right? Then we get up to 599, which is double this, right? So that's going to be the light source of, we get rid of that one. And all of a sudden we have a light source of, what is it, 599? 584 kilometers, right? Now, with the light source of this diameter, all of a sudden it takes 2 seconds to radiate its light the distance of its diameter. So it's got a more powerful, again, it's just doubled in diameter, but that makes no difference. It's taking 2 seconds, but the way I'm seeing it with absolute light, it's doubled from 299,792 kilometers to a diameter of 599,584 kilometers. So when somebody switches that sun on, it's like boom, poosh. But no, Mickey Mouse says 2 seconds now to radiate my light the distance of my diameter. We double it again, we get 1,199,168. So now we have a diameter of, what was it? 1,199,168 kilometers. Well, guess what? Now it takes us 4 seconds. 4 seconds. I am now twice as powerful as I was when I was 599,000, but now it's taking me 4 seconds to radiate my light the distance of my diameter. But with my absolute light, which I think it's fairly logical that it is, as my diameter is doubled yet again, when I turn on, we are talking some serious distance when I radiate my absolute light, right? And then we add 0.6 of the 299 onto that, and we have the diameter of the sun, 1,390,000 kilometers. And that size, I'm afraid it takes our sun 4.6 seconds to radiate its light the distance of its diameter. But with the speed that I'm saying, with absolute speed, it's that little bit more powerful. So it's gonna boom! Absolute, right? Absolute light. And then of course, I didn't want to have to bring this up, but we've got UI Scooty. I like to say it's an absolute powerhouse, but that's not true. Because at 2,377 billion kilometers in diameter, if you divide the 2 point, I'm not going to do it, you guys can do it, by the speed of light, you'll end up with 2 hours and 12 minutes. 2 hours and 12 minutes for a star. Look, to radiate light at the distance of its diameter. Two 2 hours and 12 minutes. Can you see what we're talking? So what, 30 seconds? I'd be here still. It's ridiculous. I stand by the speed of light radiating from the sun and all stars is absolute. Okay? And that is why it's stupid. So, Simon Dan, defending the moon landings, but does he think the Egyptians built the pyramids? Oh, I'd love to find out. Anyway, peeps, 39 minutes, but a quality 39 minutes, I do believe. All right, Later, peeps.